In the last session on the series Important Points to Study for +1 Chemistry Examination, 3 chapters are going to be discussed. Chapter 12, Organic Chemistry, some basic principles and techniques. Chapter 13, Hydrocarbons. Chapter 14, Environmental Chemistry. Chapter 12, Organic Chemistry, some basic principles and techniques. A leap in the field of organic chemistry started with the experiment conducted by F. Wöhler, where he converted an inorganic compound, ammonium cyanide, into an organic compound, urea. First topic in this chapter is structure of compounds of carbon and the hybridization of orbitals of carbon in these compounds. What are the characteristics of pi bonds and nature of carbon-carbon double bonds are 2 points which are essential to know the reactivity of unsaturated organic compounds. Why carbon-carbon double bond attracts more reactivity? You can answer this question based on electron charge cloud of the pi bonds. There are 3 ways to represent the structure of organic compounds, and you should know how to write the structures of organic compounds using complete structural formula, condensed structural formula, and bond line structured formula. Few examples are shown here. Students should know how to classify organic compounds based on their structure and be able to provide examples for each classification. And you can see the examples given here. You can pause the video for a minute and have a detailed look. What are the functional groups and examples of functional groups and the properties of an organic compound, which is decided by the functional group? Few examples are shown here also. Homologous series, their characteristics, how the successive members differ from each other in molecular formula, and examples of homologous series, which are also shown here. Nomenclature means naming of compounds. Students are expected to write IUPAC nomenclature of the following compounds: straight chain hydrocarbons, branched chain hydrocarbons, cyclic compounds, organic compounds with functional groups, substituted benzene compounds. Different types of isomerism shown by organic compounds is an important topic. If 2 compounds are given, by looking at their structure, students should be able to say whether these compounds are structural isomers or not. And if they are structural isomers, then students need to identify the type of structural isomerism such as chain, position, functional isomerism, and metamerism. Also, students should have an idea about geometrical and optical isomers and examples for them. Few examples of isomers are also shown here. Most important topic in this chapter is organic reaction mechanism. In this topic, the formation and characteristics of carbanion, carbocation, and alkyl radicals to be studied. Also, students should be able to compare stability of primary, secondary, tertiary carbocations and alkyl radicals, and with the help of these, the reactivity of compounds to be explained. Under the same topic, about organic reaction mechanisms, students should be able to differentiate nucleophiles and electrophiles, and examples for each of them to be also studied. Next topic is electron displacement effect in covalent bonds. In this topic, define inductive effect, origin of inductive effect, types of inductive effect to be learned. Students are advised to learn examples for electron withdrawing and electron donating groups, which are given here. One of the most important points in this unit is resonance structure. Under this topic, students should learn the definition of resonance, how to draw resonance structures, significance of resonance stabilization energy or resonance energy, and rules for writing resonance structures. Also, difference between positive resonance effect and negative resonance effect to be discussed with the help of aniline and nitrobenzene, which are shown here. Electromeric effect and its two types are the next point, and students should be able to write equations to explain those by taking different attacking reagents and examples, which are also shown here. Concept of hyperconjugation, and with the help of this concept, explain the stabilization of carbocations. That is the last point in this topic. Different methods for the purification of compounds, and which method is suitable for a given mixture of organic compounds to be studied, and a short description of all methods are shown here. They are sublimation, crystallization, distillation, differential extraction, and chromatography. Next topic is chromatography, which is a class among separation techniques. In this topic, methods such as adsorption and partition chromatography to be discussed. Components in the chromatography techniques such as stationary phase, mobile phase, and terms related to chromatography such as retardation or retention factor and retention time to be studied. Last topic is qualitative and quantitative analysis of organic compounds. In qualitative analysis, detection tests for elements such as carbon, hydrogen, halogen, sulfur, and phosphorus need to be studied. Similarly, quantitative analysis methods for determining the amount of elements such as carbon, hydrogen, nitrogen, halogen, phosphorus, and oxygen. And among them, Gelder's method is very important. In previous years, questions related to homologous series about its definition, molecular formula, nomenclature of different organic compounds, how to draw the structures of organic compounds in different methods or manner, counting sigma and pi bonds, comparison of bond length and bond strength of carbon-hydrogen bonds in different hybridized orbitals of carbon atoms were asked repeatedly in the examination, estimation of nitrogen using Gelder's method, types and principles of different chromatography techniques, resonance structure and effects of resonance and hyperconjugation. These topics repeatedly came in previous examinations. Questions such as formation of carbanion, carbocation, and radicals and their stability repeatedly came in previous examination. Chapter 13, Hydrocarbons. In this chapter, classification of hydrocarbons based on their structures are discussed. Nomenclature of hydrocarbons, isomerism in hydrocarbons, preparation and properties of hydrocarbons are the major topics in this unit. In the topic alkenes, their structure and their structural isomerism, both position and chain, are to be studied with the help of examples. 3 different preparation methods and equations have to be studied. Those preparation methods are shown here. Physical properties of alkanes such as polarity, boiling point, and solubility need to be studied. Chemical properties such as substitution, combustion, oxidation, isomerization, aromatization, pyrolysis, reaction with steam also to be studied with the help of examples. Students should know how to write the conformation of ethane using Sohor's projection and Newman projection which are also shown here. In alkenes, questions related to the reaction with electrophilic reagents, and students should know the reason why electrophilic reagent reacts with alkenes easily. How to name straight chain branched alkenes using IUPAC suggestions. Students should be able to classify structural isomerism in alkenes, such as chain and position isomerism. Also, students should be able to classify geometrical isomerism, such as cis and trans isomers, with the help of examples. Examples for both structural and geometrical isomerism. You can pause this video and learn these examples. 4 different methods of preparation of alkenes are shown here. Those methods are from alkynes, from alkyl halides, from vicinal halides, and from alcohols. Alkenes undergo addition reactions in which electrophiles add on the carbon-carbon double bond to form addition products. Why it happens and few addition reactions are listed here. Another very important topic is addition of hydrogen halides to alkenes. Generally, Markovnikov's rule is applied for this reaction. But by changing the conditions, we will be able to change the mechanism as per Markovnikov's rule, anti-Markovnikov's rules. Students are expected to differentiate both Markovnikov and anti-Markovnikov addition reaction with the help of examples. Other important reactions of alkenes are polymerization and ozonolysis. In alkynes, students should be able to write the IUPAC name for both straight chain and branched alkynes. They should be able to differentiate chain and position isomers with the help of examples, and one example is shown here. Students should be able to write equations for the preparation of alkynes from calcium carbide and from vicinal dihalides, which are shown here. Next, very important topic, why alkynes show acidic character. How they undergo addition reaction with the hydrogen and water. Next topic, types of polymerization of alkynes which can undergo is the last point in this topic of alkynes. In aromatic hydrocarbon, classify benzenoid and non-benzenoid and list examples for them. How to name aromatic hydrocarbon using IUPAC norms. Structure, resonance and stability of benzene is the next important topic. Position isomerism in aromatic hydrocarbons need to be explained with the help of examples. One example is shown here. Huckel's rule and aromaticity of aromatic hydrocarbon is also very important. 3 methods of preparation of benzene, they are discussed here. Cyclic polymerization of ethine, decarboxylation of aromatic acids, and reduction of phenol. These are the 3 preparation methods for benzene. Different electrophilic substitution reactions such as nitration, halogenation, Friedel-Crafts alkylation, and acylation with the help of the reactions need to be studied. 3 steps for the mechanism of electrophilic substitution reactions are given here, and the equations also to be learned. Addition reactions of benzene such as hydrogenation and chlorination, they are shown here, and students should be able to distinguish which groups are ortho and para directing and which groups are meta directing. Few examples are shown here. In previous years, questions came from the topics of halogenated compounds, Markovnikov's rule, anti-Markovnikov's rule, and their reactions. Incompleted equations related to the reactions will be given. You have to identify the missed reagents and complete the equations. Represent Sohor's and Newman projection of staggered and eclipsed form of ethane. This question repeatedly came in examination. Different reactions related to hydrocarbons were also repeated several times. Last chapter, chapter 14, environmental chemistry, which is relatively a small unit. First topic is atmospheric pollution in troposphere. Classify the sources of pollution in troposphere, such as gaseous pollutants, particulate pollutants, smoke, dust, fumes, and smoke. In this topic, you can expect the following questions related to oxides of sulfur and nitrogen and resulting acid rain, carbon monoxide and its toxicity due to its reactivity towards hemoglobin, greenhouse effect and gases lead to greenhouse gas effects, formation and effects of photochemical smoke, how to control photochemical smoke. Next topic is pollution in stratosphere, and in this topic, questions such as reasons behind ozone depletion and ozone hole, and these questions are repeated in previous examinations. In the topic water pollution, different types of pathogens and organic pollutants which lead to water pollution is to be studied. Significance of biological and chemical oxygen demand related to water pollution is another important subtopic in water pollution. In the topic soil pollution, major reasons behind the soil pollution to be discussed. And students should be able to list strategies to avoid and control air pollution. In the previous years, questions related to greenhouse gas effects, global warming, acid rain, ozone layer depletion, photochemical smoke, eutrophication, pesticides in soil, organic pollutants in water, suggestions to remove pollutants from water, air and soil were repeatedly asked.